Welcome to Factory Forward, the podcast dedicated to advancing manufacturing and propelling factories into the future. Today, we are thrilled to have the exceptional team from Leonardo Group USA, renowned for their expertise in lean manufacturing and mixed model line design. With decades of experience and partnerships with industry giants like Toyota, they've set the benchmark for innovative and practical industrial engineering solutions. In this episode, Rahn, Gerard Leone, and James Cope will share their insights on the evolution of lean manufacturing, the critical role of mixed model production, and how manufacturers can navigate today's challenges with adaptability and innovation. Now, meet your host, Zishan Zia.
Hi, everyone. This is Zishan Zia with the Factory Forward podcast. I am honored to have the two principals and the VP of Consulting from Leonardo Group US with us. Leonardo Group is the premier manufacturing engineering and lean manufacturing consultancy firm in the US. You think about a top 10 manufacturer in any discrete manufacturing vertical, and it's likely that they have actually worked with them or they're actively working with them. These are the guys that tell Toyota what to do. These are the guys that work with John Deere. These are the guys that work with pretty much, again, like I said, every manufacturer. You go to their website and you'll see that long list of who's who in manufacturing. Not only that, they also Gerard and Richard and James, they also organize one of the best courses in industrial engineering, most practical courses, while at the same time being very rigorous uh, as far as I've seen in the country. I've tried to attend myself a lot of industrial engineering courses, but their mixed model line design and the one that's coming up, mixed model material design courses are absolutely fantastic. Not only it's hosted at Toyota Material Handling, and you get the chance to actually explore it. And like I said, I've had the chance to be a part of that course, to attend that course. But even the crowd that's there, the students that they invite, they're top of the top. You'll see the absolute best industrial engineers on the planet probably attending their course and learning from them. And I'm curious to ask them more about that as well. What inspired them to do that? And I know that Richard has this amazing simulation software on mixed model line design and material handling as well. I'd love to ask him, learn more about it from him as well. I got the chance to work with it a little bit because they give us access during the course, and it's absolutely fantastic. It's not a beautiful 3D simulation digital twin thing, but it's something that's incredibly practical and fascinating. But I could keep talking about them, but I'll shut up now, and I'll start moving towards them because I know that you're listening to this to hear from them, not from me. So again, Richard, Gerard, James, thank you so much for joining. Really appreciate it. I'm incredibly excited to have you. Gents, can you maybe more towards Richard and Gerard, can you tell us a little bit about your journey and how Leonardo Group US was founded?
Well, I'll jump in, Gerard, if you don't mind. Thank you for the kind words, Ishan. I'm blushing. But I'll have to say all three of us have actual industry experience, which is helpful. When you're talking to people, you can actually refer to our getting our hands dirty in our past with our careers. But both Gerard and I started working for a consulting company here in Colorado called JCIT, more or less at the same time. And I hesitate to tell you how long ago, but you can kind of tell from my gray hair that it wasn't just yesterday that we started working with them. And that's where we cut our teeth. At the time, this company was really a leader in, even before the term lean was used. We called it world-class manufacturing or just-in-time or flow manufacturing. And Gerard and I, oftentimes as a team together, got to go to many of the biggest companies, not only in the US, but in the world. We were traveling all over the place. For a while, Gerard and I became the air conditioning gurus of lean manufacturing because it seemed like one week after the next, we were going to an air conditioning company. But probably most of the Fortune 100 at the time worked in some way or another with us or got exposure to what we were doing. Now, everything changes over time, and Gerard and I drifted away from that company and went off on our own, as oftentimes happens. And we were actually working independently for a while, but because we had so much in common, both of us are Latinos, Gerard more than myself. We decided to merge our talents together and form the Leonardo Group, along with some of our associates in Germany, in Europe. So that's our current organization, and we're bringing, as fast as we can, we're bringing other talented people onto the team like James. But basically, the thing we have in common is that we regard lean, and our approach to lean is not all things to all aspects of lean that we could possibly become experts in, because lean is a big world now. At the beginning, it was small, and now it's very all-encompassing in terms of things like Hoshin Kanri and strategic planning and Obeya rooms, and all kinds of aspects are kind of under the lean umbrella these days. And Gerard and I sat down one day, maybe 10 or 15 years ago now, and said, hey, we can't be the best in the world at everything. So let's find something that really adds value, that's really foundational to lean industrial engineering, and focus on that and try to be the best in the world at that. And if we can accomplish that, then that'll be a lot. And so we did. And so our basic focus from then until today is on what we regard as the bottom of the house of lean, right? The very foundation, which is how do you design a value stream properly from a workflow perspective, and how do you design a value stream properly from a material delivery perspective? And that's what we teach. That's what our customers learn from us, and that's what they appreciate, because in our estimation, that's where 80% of the benefits of lean actually come from. All the other stuff is great. We love all aspects of lean, but where the actual bottom line benefits come from is being able to execute this strategy of what we call mixed model manufacturing. And it's very much what Toyota does. So we've had a great relationship with them, again, over the last 15 years or so. And they've been willing to have us come in and teach public classes like the one you went to, because I think they know that what we're teaching is really compatible with their approach to lean as well. So that's been a wonderful relationship. So Gerard, you want to jump in and add to that?
Again, Zishan, thank you very much for the kind words. And not much to add to what Richard just said. And the way we introduce ourselves is we are the mixed model line design guys and the mixed model material flow guys. That is who we are. Now, do we know value stream mapping, 5S, standardized work? Of course, all those are tools. We don't lead with that. We do help family and friends, we say sometimes jokingly, our clients with those tools. Of course we do, but we are the mixed model line design guys. And many times, 5S, value stream mapping, that is a byproduct of a well-designed and well-balanced line. But that is what we do. And we believe we have become, don't mean to toot our own horns too much, but yes, we strive to be the best in the world. And we are very lucky that in the last few years, we have been able to get team members like James, some of the most talented people in the market, to join our team and to really live up to those standards. And that is who we are, the mixed model line design guys, mixed model material guys. And yes, James and Gary and Ryan, and they have come with different backgrounds that added to that richness of experience, but they continue to learn mixed model material management, mixed model line design, and deliver that value to our clients along with their experience. Would you agree with that, James? Is that how we go about it?
Yeah, absolutely. And I'll echo too, Zishan. Thanks for the wonderful buttering us up. Always nice. But
I think it's very
absolutely,
justified, every single word that I said, but please, yeah.
yeah, I think that, to expand on Richard, you can't be all things to everyone. And certainly you can Google and just Google lean consultant or something, and you're gonna get a plethora of what that means and what that can offer. And now you start to see lean in healthcare and lean in legal, and there's all of that that is under the umbrella that is lean. And having been in manufacturing for my whole career, I always gravitated towards the Toyota production system principles and ideals, working in aerospace and defense and CPG, et cetera, and then getting into consulting. I very much would walk into situations and scratch my head and think, man, who designed this? Who decided to build a factory this way? Why is it that way? And through those types of exercises and projects led me to working with the Leonardo Group, and it really dawned on me that for my own career, like this is where I want to be, and being able to work on whether it's greenfield, brownfield, or expansions and things of that nature. Say, all right, let's not just sort of whittle away and approve, but let's take a step back and really look foundationally. How do we design a value stream from beginning to end that takes into account not only the workstation design and standard work and all those typical lean principles, but also the material management side. And we've been able to have a wonderful and long-term partnership with Toyota Material Handling at their headquarters there, to be able to use that as a go and see for our students, to be able to have that wonderful marriage of the education aspect, the going through the material, but then going and doing a plant tour and seeing that. So very much so, to Gerard's point, not to toot our own horn, but when it comes to mixed model line design and a material flow to support that mixed model, our approach, our certification, we feel like is bar none, and that's what makes us different out in the marketplace for sure.
No, 100%. And I look for, I'm a student of industrial engineering myself, trying to build a company in that space. And I've looked everywhere to find the expertise that you guys possess and that you guys are teaching. And there is nothing in the mixed model line design, there's no curriculum of the caliber that you guys have. And what my only complaint against you guys is that you don't open that course up to more people. I think a lot more people could benefit from it. You're a little bit too selective. I almost didn't make the cut for the upcoming course, and I appreciate Richard with his flexibility in letting me in that one. But that's a big complaint that I have actually against you guys. But
We'll live with
otherwise,
that.
yeah. So kind of continuing the conversation on the mixed model piece of it. Mixed model line design is a core aspect of your offerings. Can you elaborate on what that entails? Why is it important for manufacturers in the first place?
Why mixed modeling? Because especially as we transition into the future, resources are not going to be more plentiful. We will be, as manufacturers and as a society, required to serve a larger market, more people with a limited number of resources. And to be able to do that, we have to use those resources to make more things. So specializing those resources decreases productivity. So we have to be able to make the same, and you will see this if you go to and again, I don't mean to insist too much on Toyota, but if you go to a Toyota factory, you will see an Avalon, followed by a Camry, followed by a Corolla. Because if they wanted to make only Avalons, well, there are not enough buyers for Avalons, and then it would take hundreds of millions of dollars to retool the line to make Corollas. So that is not an option. And there is not enough money in the world to set up a factory for this model and that model and that model. So what you do is you seek to understand what is the process commonality between all the different products. You find that process commonality. Then you seek to understand what is the time commonality between those different models, the materials commonality, and you design your factory around that. You design for the volume, you adjust for the differences. And that is what we teach in class. And we teach it in a very practical manner. These are the steps you follow. These are the path. This is the path you take. These are the different shortcuts you can take, and the different paths you may take in case this works or doesn't work. But there is not much of a choice. Right now, we're working with a client that the factory is this rectangle surrounded by streets. Their volume is about
Looks like Gerard froze up there.
Am I frozen?
Oh, everyone did.
He's available for me. Yeah.
Yeah, it seems that their factory is a rectangle surrounded by streets. There is nowhere to go. Their volume is about to double. We have no choice but to figure out a way to double that volume in that same floor space. And right now, we figure out a way to increase around 20% in that same floor space. And now we need to figure out a way to go another 40%. We're going to have to mix because there is no choice.
You know, it might be worth commenting too on what happens if you don't do this right. Right? Like many companies are experiencing this phenomenon of mass customization, where they started out maybe 20 years ago with a few products, and then those products get expanded in various ways. You know, different features get added, et cetera. So now, you know, the number of different kind of variants of a product that you have to build grows, right? So that's the challenge. But if you don't do it right, what happens is you introduce variability into the flow. Remember, we're trying to design a flow of work that's smooth, that's even. And when you introduce some that are harder, some that are easier, and you're mixing the delivery of materials with a lot of different kinds of components, there are a lot of things that can go wrong. And so part of the beauty of following a process that we teach is you can help not necessarily eliminate those challenges, but help understand them, overcome them, work with them, so that you can actually be successful and not experience a deterioration in productivity, for example. So if you have too much variation in the work content, you're going to have times where some workers are overloaded and some workers are waiting for work, right? Nothing to do. And so there are strategies for trying to even that up. And there's a Japanese word for that, right? Heijunka, to try to level load or smooth that out. So that's part of our strategy. And then the other bigger potential challenge that you have to get right is the material delivery, because the number of components or parts that you have to deal with in a mixed model environment could be double or triple or quadruple the number of different parts that you would have to deal with in a more, say, standardized or dedicated environment. So again, if you don't do that correctly, then you're going to be stopping the line, worst case, with nothing to work on, no parts. So these are all the challenges that you know, really behooves manufacturers to understand so that they can achieve, and it is possible because Toyota, for example, is doing it, but achieve a high level of productivity and a high level of mix in that line. But it requires...
And that brings up a point. You used a term, Zishan, that's very important. You used the term industrial engineering multiple times. And one thing that we have not done correctly in industry is to apply industrial engineering to the delivery of materials. We've done a decent job in industrial engineering when it comes to line balancing. And again, there is a lot to be done. But when an industrial engineer is hired at a factory, you can make money every day betting that industrial engineer is going to become an ME and dedicated to the line, to balancing lines, or to do standardized work or writing time studies. But materials, unlikely. Big mistake. And one thing you're going to see week after next, Zishan, when you come to Toyota, when we're doing the introductions, we're going to tell you their lines, very nice. Their materials delivery, head and shoulders above anybody else. Why? Because they put industrial engineering work into their materials delivery. And that entire class that you're going to see, 3 full days, will be dedicated to industrial engineering for materials. And that is very, very important. And for everybody in your audience, there is a big gap in industrial engineering for materials. Would you agree with that, James? I don't think I'm exaggerating in saying that.
No. And I think, to go back to your question, Zishan, we get asked all the time, well, what is mixed model? Why is that this? Why is it that? And, Gerard started by just kind of framing up at a very high level. And I would totally agree. I mean, go into literally any store nowadays and compare that to the options you had available 10 years ago, 20, 30, 40, 50, whether it's grocery store, and now you have, whether it's, gluten-free and all organic and all those different things just within one, or you want to pick going into any sort of, I'm doing a renovation, I need to pick paint or doors or whatever. There's all these options, and you look at that from a capitalistic eye, and you say, as a business, if you're going to maintain and preserve your business, you probably want to expand. Means you have to be innovative. You have to do R&D and create new products. What does that mean on the manufacturing and operations side? Is there's not an infinite amount of space. You have some amount of square footage in your facility. And so as we start to add more products, how does that go in? Where does that get stored? And if you just fast forward 10 years later, and to Richard's point, now we have, 1,000 different part numbers where we used to only have 100. Now within those 1,000, there's sub-assemblies and subcomponents and different variations. Where does that get stored? How does that get managed? How does that get to the line? And if we're going to have a much more complex production schedule, whereas 50 years ago, I made 1 product or I made 3 products, those things were a lot easier to manage. Now, designing the line and the materials to support the flow of that line takes industrial engineering. And to Gerard's point, there's plenty of brain power and effort and use cases and books written on, I think, a lot of just the pure value stream. But one of the things that I think is beautiful about our approach is if all we do is focus on the value stream, and yet we don't really take into account the material side, the management of those materials, I think we're really just creating a very efficient line that's going to starve itself quite quickly. And so how do we ensure that industrial engineering side really takes a look at the full circle when it comes to manufacturing a good or a widget? So very much so, Gerard, I would agree that there isn't a lot out there when it comes to pure focus on the materials management side. As you begin mixing more and more, which at the end of the day, any business is going to get into that. If they want to survive and grow and thrive as an organization that manufactures any good, you're going to start adding variation, because the market is going to say, you know what, I really like your product, but this one over here is blue or red or has this feature or that feature. So you're going to have to start mixing products no matter what, because the market is going to demand it of you.
Just a quick comment. You know what's funny, Richard? James started his point by talking about someone shopping 20, 30, 40 years ago. You and I were shopping 40 years ago.
Hey, don't remind me.
While these two were probably in diapers or not even alive 40 years ago. Do you think that was a dig? Do you think that was a dig?
Yeah, I mean, we've reached a level of experience where we start sharing stories with people who weren't even alive when those stories took place. even with James here.
No, 100%. And I was actually just looking at this McKinsey report, for what it's worth. They have this, McKinsey and Company has this white paper on Industry 4.0, capturing value at scale in discrete manufacturing. And they're talking about, Industry 4.0 technologies, but also other kind, lean manufacturing and those kinds of things. And they say that one of the biggest drivers behind the need for these solutions and technologies and techniques is exactly model variation and product variation that absolutely needs to happen in these facilities. And Gerard, I'll also attest to the fact that, so again, in the last course, mixed model line design, when I attended that one and you took us through that Toyota material handling facility, I've had the chance to visit literally 100 plus factories at this point, and it was the most sophisticated material handling situation that I've seen. I think every 8 minutes or so there's this, or every 28 minutes there's this cadence of forklifts showing up just in time. One of the most sophisticated kind of situations there, and I was really intrigued and surprised at how somebody can run that so efficiently and with so many interdependent components. So
and it's not even automated for the most part.
Completely manual still.
With very little automation. Little automation. They automate only when they can identify the value of automating. They have implemented a few AGVs, but mostly hand-me-downs from the automotive plants. Yeah,
makes sense. No, I love it. So kind of continuing the conversation, since you're talking about Toyota material handling, I went on your website. I also saw mention of Linde Group. I don't know if that's how Linde or Lind Group. You've worked with these kinds of companies. Can you share some of the insights into the challenges and successes from those projects?
Well, challenges. There's every project, and this is what keeps us coming back to the well. What makes this job interesting is the fact that every project has some kind of a challenge. We always come to the table with a basic understanding or a basic idea. We want to implement mixed model flow, single piece flow. We want to see the product flow one at a time. We want to standardize the work, and we want to synchronize the work, and we want to synchronize how the material meets the product whenever is needed, in the quantity that's needed and the time that's needed. But then reality dictates what that flow looks like. So one of the case studies that you're going to see on our website is Shot Sports. And we showed up at Shot Sports knowing, well, quite frankly, not much about football helmets, and actually on this one, it was we were not building new product, we were refurbishing. So okay, now added challenge. Hey, more interesting even, very good group also to work with in Pennsylvania. So we showed up and we said, okay, let's meet the challenge. So if you have, and again to your audience, if you have a family member that plays or played football in high school or college, all that equipment gets refurbished every year. Normally, a high school doesn't have the funds to buy all the equipment every year. So that gets sent to be refurbished. We were lucky to work with the largest refurbishing facility in the country. As a matter of fact, we helped them consolidate multiple ones into the largest one in the country. And the way that works is those helmets come in and they have to be disinfected first. They actually
Good idea.
They stink pretty. They're pretty stinky. And then when it comes, and then they get put away to be then brought back to the factory, and then they have to be disassembled and then refinished, painted, reassembled. But here's the interesting part. We said, yeah, well, we're going to flow one at a time. Well, our unit of flow there had to change because you cannot flow a helmet at a time per se. Our unit of flow had to become the team. So then we had to reconfigure our thought process to actually flow an entire team all at once. Once we schedule the entire team, then the single helmet flows as long as you keep the team together. Why? Because then they have to enter the paint tunnel, by the way, the only facility in the country that has a paint tunnel because of their volume. The entire team enters the paint tunnel. They are painted. They come out on the other side to go to the final assembly lines. And then again, you have to keep the entire team together through final assembly. Then again, this was a unique challenge for us in terms of understanding that the unit of flow had to go from the single helmet to the entire team. And also, we had to apply some learning from a project that Richard did, which is going to sound completely bonkers, but one of the projects that Richard did for refurbishing landing gear, football helmets, oh, of course, they are completely the same. Well, no, they're not, but when you refurbish landing gear, you have to make a decision when you tear it apart, which parts you replace, which parts you keep. Very similar, believe it or not, with football helmets, because there are certain parts you replace, certain parts you keep to minimize costs for the high schools. And those parts then are delivered back to final assembly, new ones and old ones. Those are delivered and they have to meet the shell for final assembly. Believe it or not, very similar to the way that Richard designed that line for refurbishing landing gear. So we did learn from that for football helmets. Different unit of flow, but same principles, and we were mixing there too. Our final assembly lines, fully mixed model lines. So,
you know, Zishan, in terms of case histories, we have like hundreds, right? And I think we really should do a better job of documenting those. You saw a few on our website, but we've worked with literally hundreds of companies. I don't know if it's more than hundreds, but quite a few in a variety of industries. And sometimes people, when they hear us talk about mixed model manufacturing, they ask themselves, well, is my company really a good candidate for this or not? And I'll have to say that in the United States anyway, today, most or many of companies are good candidates because that's kind of how we do things here. any kind of mass production manufacturing, like making baby diapers or something like that, that's not a mixed model opportunity. That's a huge factory, producing millions of diapers, for example. And oftentimes that happens somewhere else in another country. But a lot of the manufacturing that's here in the United States is mixed model manufacturing. But there are some industries that don't fit that well, to be brutally honest. For example, I worked with a bottling company in California. They were filling sports drinks and water in some cases, plastic bottles at 700 bottles a minute. It's quite an amazing thing. But the challenge there is the entire factory was like one machine, because all the different processes were connected via conveyors. And once that's designed and put in place, it's pretty hard to change it, right? Pull out the filling machine and put in another one. That's not going to happen. So there are plenty of opportunities to improve, but they're more in the range of changeover reduction, setup reduction, or SMED, and 5S, and maintenance and material related.
But you may recall lesson 14 from the last class you attended, Zishan.
Yes, sir. Absolutely.
Yeah. Okay.
Yeah, the only thing I would add is, you said what are some of the challenges and things like that, and to expand on Gerard, we have the wonderful opportunity to go into factories every single week, every single month, every single year, and so we do get to see a lot of that variety, and it does keep us coming back to the well. We love manufacturing. That's why we're here. And to me, what's really wonderful about the Leonardo Group is we go into it with our idea. We have our intellectual property of our roadmap, our mixed model line design and mixed model material flow of like it's built upon, to Richard's point, the hundreds of projects, the hundreds of clients we've worked with. That how many times have we gone through a large scale capital project or large scale improvement or whatever, and then we get through it and we look backwards and we say, man, that could have been a lot better if. And so we go into every plant with that experience, and I equate it to our prospects and clients that wouldn't you love to have a cheat sheet that you knew would make sure that you turn over every stone and you get the best solution possible when it comes to designing out a value stream for a spin of mixed model. And so, going into every single client, a very, very important part of our relationship with our clients is to walk that value stream, to scope out what we're looking at. And if we're going to design something that will flow, that's what we're looking at. And to sort of visualize that, if we're going to start at the beginning of the river and just walk along the river, where do I see the process not flowing? Is it because of X, Y, or Z? And that could be poor line design. There's no standard work. There's no the organization of the work cells, the transportation of the materials. Is it improper tooling? Is it bad scheduling? You get into all these different types of conversations by simply having our known best way, our standard work of our roadmap, and walking that value stream to see, are we flowing or are we stopped? Are we, is that river dammed in some way that we just need to free that up so that the process can flow a lot more freely and smoothly? And so every place we go has got some sort of issue around that. And I think that's the wonderful part of working with our clients, is to be able to help them realize and help them see that inefficiency, that blockage of flow, and working and coaching them through those solutions.
It's working with them. That's always the way we want to approach. It's working with the client, looking for the best solutions with them. Rarely we want to tell them, hey, look what somebody else is doing. You have to copy, or you have to emulate. Every factory, every enterprise, they have their processes, their cultures, their parts, their people, and what you want to do is help them become the best they can be. You don't want you cannot get everybody to be Toyota or to be or to be a GE Medical or to be somebody else. You just want them to be the best they can be.
Makes
That's the
sense.
way we approach it.
No, 100%. I also think that there is so much in lean manufacturing and just a set of non-technical approaches that well, as in software or hardware technology or OT approaches that you can apply to massively improve productivity, quality, and safety, and all those things. But wanted to change gears a little bit. I know that Gerard and Richard, you've also been involved in software solutions. You've built, you currently have a simulator of your own. How do you see that space contributing to lean manufacturing, or even the broader industry 4.0 space? How do you see those technologies and the impact? First of all, if you can tell me a little bit about your own solution, your simulators, and then kind of expand out from there.
Sure.
When Richard was a little too humble on this one. When Richard mentioned that back in the in the late 90s we parted
late 1800s, right?
in the late 90s we parted ways. He went to work for a consulting firm specialized in simulation. He actually went to sort of pursue a career in simulation. So he got really good at that stuff. Right, Richard, you really wanted to get good at that stuff.
Yeah, that was the plan.
That was the plan. Didn't pan out exactly that way, and then Richard and I joined forces together because we wrote our first book together back in 2000, to be precise. As a matter of fact, there's a picture of the cover of the first
I've
book.
got one right up
It's
here.
on my wall.
Yeah.
It's on my wall.
Yeah.
The way we landed on simulation, again, I don't think we ever abandoned the idea, but for a specific project where we had, and correct me if you think I'm wrong on this one, Richard, we had some, and I prefer to not completely disclose client, we did have some acrimony with this client because we had some difference of opinion as to some of the data gathering. So we reached out to our dear friend, Dr. Jalal Kaplan, and Dr. Kaplan helped us develop a simulation software to help out this client. And this simulation software helped us adjust the line design to make it better for this client. And it ended up being an outstanding line. I mean, it was an incredibly successful line. To this day, is a showcase line for them. We retained the IP for that piece of software, and decided to incorporate it to our website. It got rewritten for our website. We always say that we don't claim that ours is a competitor to the big ones in the industry. We never say, well, you have a choice between Simulate or
Pro Model,
or us.
Arena.
No,
Yep.
no, that's not the case. But if you want to learn Pro Model, see you in 18 months. If you want to learn ours, hey, come sit down with me in 2 hours, you're using it.
Yeah.
That's
the real motivation for me, just to give you a little more backstory, when Gerard and I were working together back in the late 1800s on these projects, we'd like to say that everyone was outstandingly successful, but that's not always the case, right? There are always things, especially when we were just learning ourselves, where things could have been done better. And there was one case that I was in charge of that ran into some issues. And when I looked back on it, I realized the main issue was that we didn't understand, as consultants, we didn't understand the impact of variability because it was too complex to understand in your head, because there are too many sources of variability. And when they all combine, then how is this particular mix of products going to respond in the line? There's no way to really know that. I mean, you could have some intuitions as a lean consultant, but you couldn't really know. You didn't have science behind it.
Yeah, you combine human variability with short takt time.
Yeah, short takt time, variable work content, et cetera, et cetera. So that's motivated me to want to know more about simulation, because I thought, well, I'd been exposed to discrete event simulation modeling in business school when I was working on my MBA, creating models for ski areas. Of course, we're here in Colorado, so that made sense. So I knew a little bit about it, but I wanted to find out more. And I joined this company in San Diego as their lean guy on their staff, with the thought that I might become a simulation, specialist. But I realized after a while that to really get good, just like so many things, to get really good at simulation modeling, I was going to have to become a full-time simulation modelist. I wasn't going to be able to get really good at it in my spare time, basically. Or maybe somebody could, somebody in this world could, but not me. So I had to make a career choice, and I decided to go with lean rather than simulation modeling, but I still loved it and still wanted to use it. So Gerard was alluding to this project we had where I went back to the original company I worked for, and they helped us develop this simulation model, discrete event simulation model, for a Fortune 100 company that resulted in learning a lot about that line and making some improvements. So we've really made simulation kind of a requirement, right? Maybe not for everything. I mean, maybe if you have a small assembly cell, you don't need to have a big fancy model. But for almost everything else, we really like to have a simulation model as kind of a electronic wind tunnel, right? Test the design in various scenarios of mix and volume, so that we can, because a bottleneck in a flow line is not always in the same place.
Yeah.
Right. You could have a change of mix, and all of a sudden the bottleneck that was here, the constraint that was here, is now somewhere else. And it's very difficult or impossible to just understand all of that subtlety in your head. So we fortunately have the software ourselves, and the biggest advantage of that software, in my mind, is that it has a very low learning curve. If we tried to add a lot of features and bells and whistles and 3D modeling and digital factory stuff, hey, I love that stuff as well, but you wouldn't be able to implement that very quickly and easily. So we deliberately scaled back on what it can do, but we can literally build a model in a few hours. In fact, I've even written some Excel macros to generate the simulation model based on our static line design data. And with a single click, it'll take that data and put it into the format that our simulator can use. So that's the main advantage. Other than the basic, the engine of simulation modeling, discrete event simulation modeling, is basically the same. No matter what software you're using, underneath the hood, it's running the same way, right? The logic of discrete event simulation modeling is pretty standard. And what these different software companies will do is add features, right, on top of that. But we're just trying to take it down to the basics. Let's design a value stream. Let's look at where the bottlenecks are. Let's look at utilization, capacity, productivity, et cetera, and do that as efficiently as we can. And I think we've achieved that.
No, yeah, I've also observed that sort of thing. I was talking to somebody, met her at a conference. So this lady who was just wrapping up her PhD at the University of Washington, in discrete event simulation, she went to Amazon to build, to set up their discrete event simulation work. Recently, I was talking to somebody at the University of Waterloo who's now going into another organization, and so essentially to use a lot of those 3D discrete event simulation tools with physics modeling and whatnot, you almost really need literally need to hire PhDs to
Yeah.
get that
Well,
stuff set up.
My point exactly.
Jalal is a PhD.
Yeah, Jalal was the guy that designed it was a PhD, as a matter of fact.
Yeah, still
Yeah,
is.
yes,
I didn't revoke
still
it.
alive. Yeah. He didn't get decertified. Yeah,
Yeah.
true.
Yeah.
Anyway, so we're very big fans of it, but I'm proud of the fact that we have something that people can actually use.
Yeah.
Right?
Yeah,
Not becoming-
and that's the key is to be able to use it. And at this point, we treat it as a requirement.
Yep.
Just go ahead, enter the model, and run it. Once you click run, within 10-15 seconds, you have an answer. And then rerun it, change the scenario, rerun it, change the scenario, rerun it, change the number of IPKs, rerun it, change the volumes, rerun it. And in that way, you can really test your static line design, which is, again, Sisha, what you learned in class. That conceptual design that your team put together, we take that, we load it into the model, and then we test it. Those IPKs that you guys played with, we put into the model, we test it.
Yeah.
And then we add, subtract, and then we strengthen that conceptual design.
Yeah.
Then we take that, we put it into CAD, and then that is what we deploy.
And I'm reminded of a story from Jim Womack. You'll remember the story, Gerard, where he said that when he goes to companies, he sometimes gets the feeling that people regard Kaizen as like the solution, right, for design. But he said actually what Kaizen is in these companies is rework. It's rework.
Absolutely.
It's trying to fix something that wasn't done right the first time.
Yeah.
So by modeling, we're hoping to reduce, maybe not eliminate completely, but reduce the need.
I love that characterization.
Yeah, and to Gerard's point, it's part of our roadmap that why would you not test something that you've designed, right? And I think that Richard's point of an electronic wind tunnel, if we're going to go through the exercise of redesigning a factory or redesigning the value stream, wouldn't it be nice to test some theories? Should we have station 3 in parallel or series? Should we have a 1-unit buffer or 3 units or 5 units? And so as we sort of turn these knobs and pull on this lever, it's in a very safe environment. It's just a simple computer software versus, hey, let's go come in early on a Saturday and let's rearrange some of these workstations and let's try this and try that. So you certainly tighten that feedback loop a lot earlier in the design process, and you really also get a much better sense of optimizing that design so that your known conceptual design, your actual putting, moving things out on the physical space out there on the line. And so from a change management perspective, with all of the team members and the shop floor personnel, everybody's looking at you saying, is this going to work? We've come into it testing some of these things so that we avoid the large mistakes, or it's a lot more fine tuning than trying to go out to Kitty Hawk and put this thing that we built in our garage into flight for the very first time.
I love that. I know we are running up against time. Briefly, what advice would you give to manufacturers looking to stay competitive in today's markets, and what the market that you foresee coming up? I know we briefly touched about that, but like in a couple of sentences, what should be manufacturers looking at, to stay competitive? So world is changing, as you talked about, and
you mean besides engaging us, obviously.
Yeah,
of course, absolutely. Yeah.
Well, James,
Closing thoughts. Yeah.
My parting shot is very simple. Keep an open mind. Keep an open mind. The world is changing. Yes, there are some principles that are foundational, but the world is changing. Keep an open mind. And when you see new technologies coming, this idea that this is going to take your job, this is going to take my job, no, that's not going to happen. And I actually, again, I have to commend you in your company for the names you picked for your products. Copilot. That is a perfect name because this is not here to take your job. This is here to be your co-pilot, your support, your sometimes what we like to tell our clients is, we're here to work with you. Sometimes you borrow my brain, I borrow your brain. This is to support you. So keep an open mind. That is what I would tell manufacturers. And yeah, we believe that mixed model line design is the solution. But don't take our word for it. Just do your research. Give us a call. We'll be happy to help. But keep an open mind.
And Zishan, one of the things that I've been working on, but with the team, is taking the roadmap that you were exposed to, the mixed model line design roadmap, and then we have one for materials as well. And that's made up of a bunch of discrete steps, right? Tasks. And for each of those tasks, one thing I've been doing is looking at each one and saying, how can we do this task more efficiently, or better, or faster, or cheaper? In other words, is this task something that a human really needs to do? Or is it something that's amenable to a simple automation, like maybe just as simple as an Excel spreadsheet with a macro? Or is it something that could really benefit from AI kinds of tools, like retrocausal, right? Like the assembly copilot. So I'm trying to go through the literally hundreds of tasks, right, for those two roadmaps, and classify them and get some feel for where are the opportunities in the future to do things faster and better. Because even today, to rebalance a line, even with a company as experienced as Toyota, it takes weeks and weeks of engineering work to do that. And if we could come up with even semi-automated ways of improving that process, that would be a hugely beneficial, right, for all the high-paid engineers that are involved with that. So that's a direction again that we're exploring. How can we leverage AI, because it's happening pretty fast.
Yeah.
Yeah, and I think my closing comments to your question is that, maybe to quote Sam Cooke, is a change is going to come. And we have to keep that mindset that in manufacturing today, change is going to come. And so those that adapt well to that change, trying to take an attitude that, hey, we're going to forever make this product, we're going to forever make this product mix, is foolish. And I think the leaders that embrace the idea of mixing, leaders that embrace that we're going to continue to have more and more pressure on our resources, more and more pressure on our labor, more and more pressure to be cost competitive, you're going to have to be innovative. You're going to have to change. And so manufacturers that adopt that and do more in the same footprint are able to mix more products, have more throughput, have increased inventory turns through those same facilities while offering to the marketplace new things, different variations. They're gonna gain market share and continue to thrive. And so whether it's things like AI and incorporating that into their own standard work, we're doing that just like many others in our own design. For when it comes to our roadmap, where are things that are overly cumbersome? Where are things that take a lot of brain power or repetitive, et cetera? We have to understand that change is still going to come in our own industry, in industrial engineering, et cetera. So I think that embracing that change is the norm, and how you adapt and adopt new technologies, adopt new processes is important.
I love that. Really appreciate it. Again, Gerard, Richard, James, fantastic having you on. There's so much more that I'd love to talk to you about and get your thoughts on, but for this episode, I think that'll have to be sufficient. Thank you so much. I really appreciate it, and I know that our audience is going to absolutely love it and learn a ton from this conversation. Thank you, sirs.
Excellent.
All right, have a good one. Until next time.
Always good speaking with you.
And that's a wrap on this powerhouse episode of Factory Forward. If you love this episode, share it with your network and keep the conversation going on social media using #FactoryForward. Until next time, keep challenging the status quo and striving for excellence. Thanks for joining us, and we'll catch you in the next episode of Factory Forward.